Hi, today we're going to be talking about 3.3 optimization with linear programming. We're really only going to have one example. A lot of times you're going to be given the inequalities and then you're going to be given some function and you just have to maximize or minimize that function by plugging in all the vertices of your solutions to your systems of inequalities. This one's just a more advanced problem that we actually have to come up with the inequalities first and the equation that we're trying to maximize in order to find out what the solution is for the problem. So it'll be nice because it's just one example, but you'll see it's kind of a beast of a problem. So let's get started. The example says each week Mackenzie can make 10 to 25 necklaces. Okay, so if we called necklaces N, okay, N equals number of necklaces, and earrings we call E. E is number of earrings. Okay. If she earns, let's see, and 15 to 40 pairs of earrings. Okay, so we could set up a couple of inequalities there. We can say that N is greater than or equal to 10. N is less than or equal to 25. Okay, we could say, now if you remember from back, you can write that like this. You could write it as a quicker way. And maybe I'll just do it with the earrings. You can write it as 15 is less than or equal to E is less than or equal to 40. Okay, so that's another way. We could have said 10 is less than or equal to N is less than or equal to 25. So that's maybe a faster way to write that same thing. Okay, so there's the first piece of information. If she earns a profit, so we hear profit, we want to maximize her profit. If she earns a profit of $3 on each pair of earrings and $5 on each necklace, okay, that's the function I want to maximize. So maximize, I want to max 3E plus 5N. Okay, I want to maximize that. But I have to stay within the bounds here because I can't, obviously if we were really trying to maximize this, we'd just do an infinite number of necklaces and no earrings and see how that would give us, but it wouldn't. It doesn't work that way. Okay, and she plans to sell at least 30 pieces of jewelry. Okay, so she plans to sell at least 30 pieces of jewelry. So that's another inequality. We'd say N plus E is less than or sorry, not less than, is greater than or equal to 30. Okay, that has all of our information in it. So there's our, I know it looks like only 4, but this one has 2. Here's our 5 inequalities. Okay, and then this is the function. Once we find all the vertices, we're going to plug in our vertices and test to see which one's going to maximize, which vertice will maximize Mackenzie's profit. So now that we have all that information, let's move down and let's start graphing some of this so we can find our feasible region. So number 1, I don't need a graph a 4 quadrant because we can't sell a negative number of necklaces or earrings. So let's just say that N is my horizontal axis and E, so necklaces horizontal, E, earrings is vertical. Alright, N is equal to 10. Well, let's see here. I'm going up to 40 on E. I might as well go up to 40 on N as far as my axes are concerned. just so we keep that even. So that's 20 if that's 40. Okay. So let's see. 10, I know n has to be between, that's 10, and if that's 20, then 25 would be about right here. So this region in between here is my n is greater than 10 and my n is less than 25. So there's that region there. Okay, E, I have to be bigger than 15. So 15, there's that, and less than 40. Okay, so there's that feasible region there. Okay, we also have n plus e is equal to 30. All right, well, that means I could have, let's see if I can get a different color. Maybe I can get green to show up here. Okay, let's try this. So if that's 40, 30 would be here, and 30 would be here. So this line would be my n plus e equals 30. So I plug in 0, 0 is 0 greater than 30. No, it's not, so I need to shade the green this direction here. Okay, so if I look at this, maybe I can get, what would stick out? What color? Maybe an orange will stick out. Oh, red will stick out nicely. I already have red here. Okay, my feasible region where all of those are touching is inside this region here. Now, the vertices I have for this region, I have one there, one there, one there, one there, and one there. Now, I'm trying to maximize 3e plus 5 equals n. Thinking about that, I don't really have to test every vertice. I don't really need to find every vertice because I know without a doubt that if I sell, if I'm looking at like these two vertices compared to each other, this one here, I sell 20 earrings and 10 necklaces. Well, if I just go up to this part, I'm still selling 10 necklaces, but now I'm selling 40. So I know that I don't need to test that one. Okay? I also know that if I'm selling 40 earrings and I'm selling, what was that, 25 necklaces, that obviously this one is going to be bigger than this one because here I was only selling 10 necklaces. And so really I just need to find out what is that point because that's going to be my maximum profit. That's where I can go up to. That's the point that I need. Well, it's really nice. It's the line n equals 25 and e equals 40. So that is that's going to maximize my profit. So that would be the maximizer. Most of the time you'll actually have to plug these in. So we could just write out the solution now and say, I know I need to sell 25 necklaces and 40 earrings. Okay, that will maximize my profit. Okay, remember on a lot of these you're not going to be able to figure that out quite as easily on how you maximize or minimize a profit, so you will have to use a system of equations to try to solve to find each equation. So you just find which two lines are you talking about, do either elimination or substitution to find where those two lines meet. That'll give you your vertice, and then you plug in that vertice into the function you're trying to maximize. In this case, ours was 3e plus 5n. We just wanted to find what would make that the biggest. So this point for us here, 25, 40, will maximize that. And sometimes you're just going to be given functions that are harder that you can't just look and see, I know this is the point that will maximize them. Okay, and a lot of times you won't be given two simple lines like that cross here. Those were nice lines. Those are E equals 40 and N equals 25. That tells you the coordinates of that vertice. So, or vertex, singular is vertex. Bring in any questions that you have, and we'll just be practicing a lot of these problems.